generally, the electrification ship has sailed. It's out there and it's not coming back. Scooters are electrified, motorcycles are being electrified, cars are electrified, trucks are being electrified, buses are being electrified, helicopters are being electrified. There's a company that produces an EVTOL, electric vertical takeoff and landing. It's a helicopter, 2-passenger helicopter run on a battery. There are aircraft companies looking to develop battery-powered airplanes. Now, I think step one is going to be a hybrid, because you use an enormous amount of power taking off and landing. But once you're up in the air, you could probably run off of battery. The other thing that needs to happen is the power per kilogram of battery will increase as well. And I think for the airplane, it may be pushing, 1,000 kilowatt hours per kilogram or whatever that metric is.
Yeah, that's what I was thinking too. For an airplane, you will need like a huge battery. So at least at current, because Teslas are like very heavy. They never flip really, or you need to have some type of innovation that actually can, include bigger range, longer range, and with a
higher density.
Yeah,
higher density chemistry. Exactly. Right? That's where the driver goes to hide it. And I was at a Benchmark Minerals conference last week. One of the tours was to an aircraft company that was developing a hybrid airplane. So it's happening now. That's why I say the realities of life are the EV mandates don't matter anymore. Don't need EV mandates because people want to disrupt the disruptors. And so you now have, Tesla was the leader, and now everybody wants to disrupt Tesla. Everybody wants to put Tesla out of business by building their next car that's supposed to be better than Tesla or whoever, right? So
yeah, but I feel like it doesn't work like that. I think in that area, same as like in AI, I think the earlier you are engaged, you kind of like ahead. You're too far, unless they just disclose all of their advancement, that they did.
Well, the other thing you've got is people have to spend money to build a battery plant, and they're not cheap. And so when you decide that you're going to produce a vehicle and you're going to spend $3 billion on a battery plant that happens to be an NMC technology, you're not going to come in next year or next 5 years or maybe even next 10 years and change it. It'll be a slow transition from a different kind of a battery chemistry, even though there are all these people out there trying to disrupt the battery system. Sodium-ion batteries, trying to get rid of lithium-ion batteries.
What industries or markets you will see like the most significant impact from like advancement of like high purity manganese products? Besides electrical vehicles, I guess.
Well, it's electrical vehicles and it's energy storage. So you've got wind and solar or other, what you might call intermittent power generation. You need to be able to store it somewhere. And that's another place where batteries come in. I call them container-sized batteries, and you can have 1 to 100 or more of these batteries collecting the energy that's being created by a windmill or a solar plant, charging all these batteries, and then when the wind stops blowing or the sun stops shining, you drain all those big batteries. So that's a big market for NMC as well as other battery chemistries. I think there'll be more LFPs and there'll be more manganese in the LFPs. I think one of the issues that I'm hearing from the M in LFP batteries is the manganese tends to deteriorate over time, and so at a certain point, that manganese may not be there. And so, how do you keep the manganese in that battery chemistry for the longer term? I think the other thing that we'll have a lot more of is recycling of vehicle batteries, because we'll be out 15, 20 years, and those batteries will have long reached their useful life, and they'll start coming back into the recycle economy. There'll be a whole lot more of that. Right now, I'll say over the past 5 to 10 years, the research has been, let's get a battery that we can put in a car. We're not worried about recycling. Now people are worried about the circular economy, and how do we create a battery? How do we design a battery for being recycled? Because you've got all these different I'll call them chemicals and metals in these batteries. How do you design that battery to begin with so that it's much easier to recycle those materials? So I'll say the recycling portion of the business will be much more advanced than it is at the moment. Yeah, there'll be a range of different, I'll call them technologies for producing power. You'll have hydrocarbons, you'll have nuclear, you'll have solar, you'll have wind. There may be other things that we don't know about. I think nuclear is going to make a bigger comeback, especially because there are these smaller nuclear pieces of equipment that could power a specific project. Not just a big nuclear plant like a power plant that's going to power a whole area, but just specific use.